Hello, my name is Fatih Furkan Erkeç, and in this video I'm going to make lab 3.7 tuning hyperparameters. In this lab we will create a hyperparameter tuning job to tune the model that we created previously. We will then compare the metrics of two models. So let's start the lab. And I'm going to pause the video when it's creating, then I will continue. So let's continue. And objectives in this lab: use Amazon SageMaker, create hyperparameter training job, tune XGBoost model by using SageMaker, test tuned model by using performance metrics. Let's go to AWS. Let's open Jupyter Lab. So as we know the business scenario and the dataset attribute information, so I could skip these parts, and if you wanna know about, you can stop and read what this says, and maybe you can check other videos before 3.7 lab. We read these previous videos. So lab setup and importing the data and training, testing, validating the model by running following cell. The data will be imported and the model will be trained, test, validated, and ready for use. And the following cell represents key steps in the previous lab. In order to tune the model, it must be ready. And then we can tweak the model with hyperparameters later in step 2. And the following cell approximately 10 minutes to complete. And observe the code and how it processes. This will help you to better understand what's going on in the background. Keep in mind that this cell completes all the steps we did in previous lab in this model, including importing the data, loading the data into the data frame, splitting the data into training and test and validation sets, uploading the split data sets to S3, and training, testing, and validating the model with the data sets. So let's run this cell too, and I will slowly scroll through this cell so you can check the code. So I'm gonna stop the video while this cell completes, and after that I will continue. So let's continue. Uh, Step 1, getting model statistics. Before we tune the model, familiarize yourself with the current model's metrics. The setup performed a batch prediction, so we must read in the results from Amazon S3. So plot the confusion matrix and the receiver operating characteristic, which is rock curve for the original model. So as we can see, 7, 3, 2, and 19, and accuracy as we say from previous lab, and this plot gives as a starting point make a note of the validation area under curve AUG, and we'll use it later to check our turned model to see if it's better. Creating a hyperparameter tuning job. Hyperparameter tuning job can take several hours to complete, and depending on the range values that we provide. To simplify this task, the parameters used in this step are a subset of the recommended ranges. They were tuned to give a good results in this lab without taking multiple hours to complete. For more information about the parameters to tune for XGBoost, see Tune an XGBoost model in the AWS documentation, and you can see the link below the page right here. And because this next will take approximately 45 minutes to complete, go ahead and run the cell. We'll examine what's happening and why these parameters ranks were chosen. So let's run it. First, you will create the model that you want to tune, and let me stop the video while this one is complete. Okay, now the running is completed. First, we will create the model that we want to tune. Notice that the eval underscore metric of the model was changed to error 0.40 with a goal minimizing that value. Error is the binary classification error rate is calculated as wrong cases over all cases. For predictions, evaluation will consider the instances that have the prediction value larger than 0.4 to be positive instances, and the others as negative instances. Next, we must specify the hyperparameters that we want to tune, in addition to the range that we must select for each parameter. The hyperparameters that have the largest effect on XGBoost objective metrics are alpha, minimum child weight, subsample, eta, num round. The recommended tuning range can be found in the AWS documentation at Tune an XGBoost model. For this lab, we will use a subset of values. These values were obtained by running the tuning job with the full range, then minimizing the range so that we can use fewer iterations to get better performance. Though this practice isn't strictly realistic, it prevents us from waiting several hours in this lab for tuning job to complete. So we can see hyperparameter ranges in here for alpha, mean child, subsample, eta, and num round. You must specify how you are rating the model. You could use several different objective metrics, a subset of which applies to a binary classification problem. Because the evaluation metric is error, we can set objective to error. So objective metric name validation error, objective type minimize. Finally, we run the tuning shop with tuner, hyperparameter tuner, and in parentheses xgb objective metric name, hyperparameter range, max jobs. Set this to 10 or above depending upon budget or available time. Max parallel jobs, objective type, and early stepping type. Tuner fit inputs data channels and include CLS metadata false, and tuner wait. Wait until the training shop is finished. It might take up to 45 minutes. While you are waiting, observe the job status in the console as described in the following instructions. To monitor hyperparameter optimization jobs in the AWS Management Console on the Services menu, choose Amazon SageMaker and choose Training Hyperparameter Tuning Jobs. You can check the status of each hyperparameter tuning job, its objective metric value, and its logs. After training job is finished, check the job, make sure that it completed successfully. So we are in SageMaker and let's go to training and hyperparameter tuning jobs. We can see it's completed in 8 minutes, and we can see the final objective metric values in here, as you can see. So investigating the tuning job results. Now that the job is complete, there should be 10 completed jobs. One of the jobs should be marked as the best. We can examine the metrics by getting hyperparameter tuning job analytics and loading the data into a pandas data frame. From print, import print, and from SageMaker analytics, hyperparameter tuning job analytics imported, and we define tuner analytics and tuner hyperparameter tuning job analytics. Here, let's run this cell. We should be able to see the hyperparameters that were used for each job along with the score. We could use those parameters and create a model, or we can get the best model from the hyperparameter tuning job. As we can see, training job name and training job status and final objective values in here. Okay, so we run it, and now we must attach to best training job and create the model. Then we can use transfer method to perform a batch prediction by using testing data. Remember that the testing data is data that the model has never seen before. Get the predicted target and the test labels of the model, and so let's run this cell. Plot a confusion matrix for our best target predicted and test labels. So let's wait until these complete. So the thing is, conda python 3 gives error, so I restart it and run all the cells from start. So I'm waiting for it to complete. So now we can see the confusion matrix 6, 4, 1 and 20, and the new values here. TPR increased, TNR decreased, precision decreased, negative predictive value increased, false positive rate increased, false negative rate decreased, false discovery rate discrete decrease, and accuracy is but almost same. Yeah, it's same. The validation log is that. So how these results differ from the original? Are these results better or worse? Uh, I think it's not better or worse. It's about same accuracy. We can see the change in these values, but the accuracy is same. So what's the purpose of this? You might not always see an improvement. There are few reasons for this result. The model might already be good from the initial pass. What counts as good is subjective. You don't have a large amount of data to train with. You are using a subset of the hyperparameter tuning range to save time in this lab. Increasing the hyperparameter range as recommended by the documentation and running more than 30 jobs will typically improve the model. However, this process will take 2 to 3 hours to complete.